The equipment grounding conductor, or EG, plays a crucial role in electrical safety. It provides a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers or fuses, thus minimizing the risk of electrical shock. Understanding the requirements for sizing equipment grounding conductors is paramount for ensuring a safe and compliant electrical installation. National Electrical Code, or NEC, Section 250.66 and Table 250.66 are often referenced when determining the appropriate size of an equipment grounding conductor. Confusion can arise because the NEC differentiates between the equipment grounding conductor for service conductors and the equipment grounding conductor for the rest of the electrical system. The equipment grounding conductor for the service conductors connects the service equipment, such as the service disconnect, to the grounding electrode system. Its size is determined by the size of the service conductors, as outlined in Table 250.66. The equipment grounding conductor for the entire electrical system, on the other hand, connects all exposed conductive surfaces to the grounding electrode system. Its size is based on the largest ungrounded conductor in the system, as per 250.66a. Let's clarify this with an example. Suppose you have 2/0 service conductors. According to Table 250.66, you would need a number for equipment grounding conductor for the service conductors. However, for the rest of the electrical system, if the largest ungrounded conductor is smaller than 2/0, you might only need a number 6 equipment grounding conductor, as per 250.66a. It's crucial to understand the distinction to ensure you're using the correct size equipment grounding conductor in each application. Now, let's delve deeper into NEC Section 250.66 and Table 250.66 to fully understand the requirements for equipment grounding conductor sizing. Section 250.66 outlines the requirements for grounding electrode conductor sizing. It specifies that the size of the grounding electrode conductor must not be less than what is given in Table 250.66. Table 250.66 provides the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. It's important to note that this table applies to the grounding electrode conductor, which connects the service equipment to the grounding electrode. As previously mentioned, the equipment grounding conductor for the service conductors is also sized based on Table 250.66. However, the equipment grounding conductor for the rest of the electrical system is sized based on 250.66a, which considers the size of the largest ungrounded conductor. Now, let's examine the specific requirements of 250.66a. This section states that where the grounding electrode conductor is connected to a rod, pipe, or plate electrode, that portion of the conductor that is the sole connection to the grounding electrode need not be larger than number 6 copper or number 4 aluminum. This means that if your grounding electrode conductor is connected to a rod, pipe, or plate electrode, the portion of the conductor that connects directly to the electrode only needs to be a minimum of number 6 copper or number 4 aluminum, regardless of the size of the service entrance conductors. However, it's crucial to remember that this exception only applies to the portion of the conductor that is the sole connection to the grounding electrode. The rest of the grounding electrode conductor must still be sized according to Table 250.66 based on the size of the service entrance conductors. To further clarify, let's consider another example. Suppose you have 4/0 service entrance conductors. According to Table 250.66, you would need a number 2 copper grounding electrode conductor. However, if your grounding electrode conductor is connected to a rod, pipe, or plate electrode, the portion of the conductor that connects directly to the electrode only needs to be a minimum of number 6 copper. The rest of the grounding electrode conductor must still be number 2 copper. It's important to carefully read and understand the requirements of 250.66 and Table 250.66 to ensure that you're properly sizing your grounding electrode conductor. Incorrectly sizing the grounding electrode conductor can compromise the safety of the electrical system and increase the risk of electrical shock. In summary, When sizing equipment grounding conductors, remember the following key points. Firstly, distinguish between the equipment grounding conductor for the service conductors and the equipment grounding conductor for the rest of the electrical system. Secondly, the equipment grounding conductor for the service conductors is sized based on Table 250.66. Thirdly, the equipment grounding conductor for the rest of the electrical system is sized based on 250.66a. Fourthly, if the grounding electrode conductor is connected to a rod, pipe, or plate electrode, the portion of the conductor that is the sole connection to the grounding electrode need not be larger than number 6 copper or number 4 aluminum. By carefully following these guidelines, you can ensure that you're properly sizing your equipment grounding conductors and creating a safe and compliant electrical installation. Now let's discuss some additional considerations when sizing equipment grounding conductors. Firstly, it's important to consider the material of the conductor. Table 250.66 provides the minimum size for both copper and aluminum conductors. If you're using aluminum conductors, you'll need to use a larger size than if you're using copper conductors. Secondly, it's important to consider the ampacity of the conductor. The equipment grounding conductor must be able to safely carry the maximum fault current that it could be subjected to. Table 310.15b16 in the NEC provides the ampacity ratings for various conductor sizes. Thirdly, it's important to consider the length of the conductor. The longer the conductor, the greater the voltage drop. This voltage drop can reduce the effectiveness of the equipment grounding conductor. Therefore, it's important to keep the length of the equipment grounding conductor as short as possible. Fourthly, it's important to consider the type of equipment being grounded. Some equipment, such as motors and generators, may require a larger equipment grounding conductor than other types of equipment. The NEC provides specific requirements for grounding certain types of equipment. Fifthly, it's important to consider the environment in which the equipment grounding conductor will be installed. If the conductor will be exposed to corrosive environments, it's important to use a conductor that is suitable for that environment. Sixthly, it's important to consult with a qualified electrical engineer or electrician to ensure that you're properly sizing your equipment grounding conductors. Sizing equipment grounding conductors can be complex, and it's important to get it right to ensure the safety of the electrical system. In addition to the above considerations, it's also important to understand the different types of equipment grounding conductors. The NEC recognizes several different types of equipment grounding conductors, including wire type, metal raceway, and equipment grounding conductor. A wire-type equipment grounding conductor is a single conductor that is used to connect the equipment to the grounding electrode system. A metal raceway is a metallic enclosure that is used to protect and support electrical conductors. The metal raceway can also serve as an equipment grounding conductor if it is properly bonded. An equipment grounding conductor is a conductor that is used to connect the equipment to the grounding electrode system. This type of conductor is typically used in applications where it is not practical to use a wire-type or metal raceway equipment grounding conductor. When selecting an equipment grounding conductor, it's important to consider the specific requirements of the application. The NEC provides specific requirements for each type of equipment grounding conductor. It's also important to ensure that the equipment grounding conductor is properly installed and connected. A poorly installed or connected equipment grounding conductor can be ineffective and can increase the risk of electrical shock. In conclusion, sizing equipment grounding conductors is a critical aspect of electrical safety. By understanding the requirements of the NEC and considering the various factors that can affect the size and type of equipment grounding conductor, you can ensure that you are creating a safe and compliant electrical installation. Always consult with a qualified electrical engineer or electrician if you have any questions or concerns about sizing equipment grounding conductors. Remember to always prioritize safety when working with electricity. Electricity can be dangerous if not handled properly. Always follow the safety guidelines outlined in the NEC and other applicable codes and standards. And always disconnect power before working on any electrical equipment. Here are some additional points to consider regarding equipment grounding conductors. Firstly, the purpose of an equipment grounding conductor is to provide a low impedance path for fault current to return to the source. This helps to ensure that overcurrent protective devices, such as circuit breakers and fuses, will operate quickly to clear a fault, minimizing the risk of electrical shock or fire. Secondly, the size of the equipment grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. Table 250.122 in the NEC provides the minimum size of equipment grounding conductors for various overcurrent protective device ratings. Thirdly, equipment grounding conductors must be installed in the same raceway or cable as the circuit conductors. This helps to ensure that the equipment grounding conductor will be effective in clearing a fault. Fourthly, equipment grounding conductors must be properly connected to the equipment being grounded. The connection must be made in a way that ensures a low impedance path for fault current. Fifthly, equipment grounding conductors must be protected from physical damage. This can be done by installing them in a raceway or cable, or by using a suitable type of conductor that is resistant to damage. Sixthly, equipment grounding conductors must be identified. This can be done by using a green color or by marking the conductor with a green stripe. Seventhly, equipment grounding conductors must be continuous. There should be no splices or breaks in the equipment grounding conductor. Eighthly, equipment grounding conductors must be properly terminated. The termination must be made in a way that ensures a low impedance path for fault current. Ninthly, equipment grounding conductors must be inspected regularly. This helps to ensure that they are in good condition and are properly connected. Tenthly, equipment grounding conductors must be tested periodically. This helps to ensure that they are effective in clearing a fault. 11th, equipment grounding conductors play a critical role in electrical safety. By following the requirements of the NEC and other applicable codes and standards, you can help to ensure that your electrical system is safe and reliable. 12th, always remember to consult with a qualified electrical engineer or electrician if you have any questions or concerns about equipment grounding conductors. They can provide you with the information and guidance you need to ensure that your electrical system is properly grounded. 13th, understanding the nuances of equipment grounding conductors and their proper sizing is essential for anyone working with electrical systems. This knowledge contributes significantly to preventing electrical hazards and ensuring a safe working environment. 14th, it is important to stay updated with the latest revisions and amendments to the NEC, as the requirements for equipment grounding conductors may change over time. 15th, proper documentation of the equipment grounding system, including conductor sizes, routing, and connections, is crucial for future maintenance and troubleshooting. 16th, regular inspections and testing of the equipment grounding system can help identify potential problems before they lead to hazardous situations. 17th, ongoing training and education on equipment grounding practices are essential for electrical professionals to maintain their competence and ensure compliance with safety standards. 18th, a well-designed and properly installed equipment grounding system is a fundamental component of a safe and reliable electrical system, protecting people and property from the dangers of electrical faults.